tree with a rating of 5 exhibited no salt injury. So like vigor ratings, degree of salt injury also varied by cultivar. Again, here we're looking at an average of all the observation dates. And again, you can see that Elliott shows the least amount of salt injury and Peru the most, with the other cultivars scattered in between. We also measured, as I indicated, trunk diameters in each dormant season, and you see that data here. Both vigor and salt injury ratings that we just looked at were similar in ranking to the actual seedling growth rates determined by these dormant season trunk diameter measurements. So Elliott, the red line here, was the cultivar with the highest vigor and the least amount of salt injury, and you can see it grew faster, considerably faster than the other cultivars. Again, at the other end is Peru, which had the lowest vigor and salt injury ratings, and you can see that it also grew quite a bit more slowly than the other cultivars. So here I've simply ranked the cultivars with respect to each of the measurements I've talked about so far: salt injury, vigor, growth, and survival. And although the rankings do vary slightly, it's very clear that Elliott is at the top of the rankings and Peru at the bottom. The column in blue here is an average. It represents the average of all of the other measurements. The order of performance from best to worst was Elliott, Ideal, Riverside, Shoshone, VC 168, Giles, and then Peru. We also analyzed nutrient concentrations in leaf tissue that we collected in October of 2019. Analysis of 2020 samples has not yet been completed. The cultivars exhibited differences in leaf concentration of several nutrients: phosphorus, magnesium, potassium, sodium, and chloride. Here I'm just showing you in the lower left, the sodium and potassium leaf concentrations. And we can see, if we look at either leaf sodium in the blue or leaf potassium, the green bars, we can see that Elliott is distinguished from the other cultivars. Elliott had the highest leaf potassium and the lowest leaf sodium of the cultivars tested. This lowest leaf sodium supports Miyamoto's observation that cultivars exhibiting the greatest tolerance to salinity also contain the least leaf sodium. So interestingly, if we look at the potassium to sodium ratio, and that's shown in the upper right here, we see the Elliott leaf tissue potassium to sodium ratio was nearly 4 times greater than that of Giles, the next highest cultivar, and nearly 10 times higher than Shoshone, which was the cultivar with the lowest potassium to sodium ratio. We're going to come back to this potassium sodium ratio in just a moment. Here's the relationship between leaf sodium concentration and the salt injury rating. The individual symbols represent a group of trees. Because of missing plants and the very small size of some of the remaining individuals, it was necessary to collect composite samples. So we have 4 samples from each cultivar, with the exception of Peru, where we could only collect 2 samples. Regardless, a clear trend is observable. The greater the concentration of leaf sodium, the more observable salt injury there was. And again, this supports the previously discussed findings of Miyamoto et al. There's similarly a relationship between leaf potassium concentration and salt injury, where the higher the leaf potassium was, the lower the salt injury. However, this relationship, and I think you can see it in this diagram, is a weaker relationship than that we just looked at between leaf sodium and salt injury. However, if we look at a plot of salt injury versus leaf potassium to sodium concentration ratio, we see that this relationship is stronger than the relationship between salt injury and either leaf sodium or leaf potassium alone. So plants with the ability to absorb potassium and exclude sodium were able to tolerate soil conditions in this study better than the other cultivars, or better than the other plants. As a group, Elliott had the highest potassium-sodium ratio, but there were some Giles seedlings, represented by the little plus sign here, that were comparable to the Elliott's. And this is, again, a result of the genetic variability exhibited by these open pollinated seedlings. As hypothesized, there did appear to be a relationship between geographical origin and tolerance to salinity, or to salty, high sodium, poorly drained soils. Elliott, the top performer, was a seedling selection from Florida, as I indicated, but the actual point of origin is suspected to be somewhere in northern Mexico. If so, it's the most southwestern cultivar of those tested, and might be expected to be the most tolerant of these soil conditions. Ideal and Riverside, which are selections from Texas, were the next most tolerant. The 2 cultivars from the Midwestern US, Peru and Giles, again from Missouri and Kansas, were the least adapted to the conditions of our study. I'm confident that advances in developments in pecan rootstock propagation and genetic mapping will lead to a new generation of pecan rootstocks. Cloning will produce genetically uniform rootstocks and provide unique opportunities for rootstock improvement and selection. Our research has provided some clues to the mechanisms of tolerance to certain adverse soil conditions. In addition to exhibiting unusual tolerance to these conditions, Elliott is unique among the cultivars that we tested in terms of leaf potassium and sodium acquisition. Leaf potassium to sodium ratio can perhaps be used as a screening tool for pecan salinity and sodicity tolerance. If genomic characteristics can be linked to the ability to maintain high foliar potassium to sodium ratio, this might provide a marker that can be used to manipulate genetics and to achieve desired rootstock properties. So before ending, I want to acknowledge support from a USDA NIFA grant and from research donations by pecan growers in Arizona. Seeds for this study were provided by Linwood Nursery in California, Farmers Investment Company, or FICO, in Arizona. Seedlings were grown by Savannah Nursery, also in Sahuarita, Arizona. And most importantly, thank you for the opportunity to talk with you today and for your time and attention. If there are questions, I will.
Vienen las preguntas. Bueno, buenas tardes. Vamos a hacer una revisión sobre el aspecto de las preguntas que pudo haber habido para el doctor Walworth en su excelente presentación sobre el uso de los portainjertos en el cultivo del nogal. Aquí nuestro productor nos está mostrando la relación de preguntas. Pues parece que no vemos hasta ahorita, no vemos ni una pregunta relacionada específicamente con el aspecto de portainjertos. Ah, sí. Bueno, nos están preguntando sobre un usuario, dice que aguas de riego con una conductividad eléctrica superior de 3.2% y con pH alto se bajan con ácido sulfúrico, las sales hasta un pH, el pH del suelo baja hasta un pH de 5 a 5,5. Esto puede causar problemas de absorción de nutrientes y quemadura en el follaje. Esto está pidiendo un comentario. Si me escucha el doctor Walworth, excuse me, doctor Walworth, can you hear me? No está. Parece que no lo tenemos en línea. Efectivamente, de las experiencias, del doctor Núñez no se encuentra ahí, que también tiene algunas experiencias con este tipo de trabajos. Doctor Núñez, ¿podrías también participar en esta respuesta? Bueno, nos está escribiendo el doctor Walworth, algún problema tuvo para conectarse. Sí, Humberto, están preguntando sobre el uso del ácido sulfúrico, si es que ves la pregunta, si no...
Sí, bueno, el ácido sulfúrico, lo que nosotros lo utilizamos, pues básicamente es para reducir el pH. Pero la salinidad no se mejora con el uso del ácido sulfúrico. Las sales ahí están. Lo que sí podemos reducir es el pH, y al reducir también los bicarbonatos, también se puede mejorar un poquito la relación de absorción de sodio. Pero en sí, las sales ahí continúan en el agua de riego.
Muy bien.
¿Está escribiendo algo el doctor Walworth?
Sí, no sé, pues sí tuvo algún problema de conexión, pero sí nos dice que puede responder preguntas a través del chat. Obviamente le pediríamos a los que gusten, la hagan en inglés, obviamente para el doctor, ¿no, Humberto? Creo
Sí.
Que hagan su pregunta en inglés, y él en el chat que tienen todo el mundo, tenemos disponible, ahí pueden hacer la pregunta, sí, y él con gusto las va a responder a través del chat, nos está comunicando.
Es la única pregunta que se mira, ¿verdad? Con relación a lo...
bueno, tenemos otra, perdón, Humberto, a ver si podrías aportar algo de la doctora Damaris, conocida de nosotros en Chihuahua. Dice que si hay investigaciones acerca del comportamiento del nogal en altas concentraciones de sulfatos en el suelo. No sé si tengas tú alguna...
No, yo no tengo, no tengo ninguna experiencia acerca de lo que es el altos niveles de sulfatos en el suelo. En donde pudiera, a lo mejor hay veces que inclusive se usa la aplicación de azufre a través del agua de riego con los quemadores de azufre. Y hasta ahorita no hemos visto, no he encontrado problemas con los sulfatos, ¿no?
Muy bien. Pues esas son las preguntas que hubo aquí para el doctor Walworth. Si nos está escuchando, le agradecemos su excelente presentación, doctor Walworth. Thank you.